Assalamualaikum. My name is Nur Adi Ashkin binti Azlan, number matric S72091. Today I will be presenting about ocean iron fertilization. What is iron fertilization? Iron fertilization is the international addition of the iron to the ocean water to stimulate phytoplankton bloom. Phytoplankton absorb CO2 during photosynthesis, and when they grow in a large number, they can remove significant amount of the carbon dioxide from the atmosphere. So the main purpose of OIL is to enhance carbon sequestration, that means storing carbon in the deep ocean by increasing phytoplankton growth in the area where iron is naturally limited. The iron hypothesis. This idea began from scientist Charles. He said that some parts of the ocean have lot of nutrients but low phytoplankton because they don't have enough iron. He believed that adding a small amount of iron could cause a big increase in phytoplankton growth. Since 1990, more than 13 experiments have supported his theory, showing that iron can boost primary production. There are three main reasons why OIL is important. First, it helps with climate change by removing CO2. Second, it helps scientists understand marine ecosystem, how nature supports life. Third, it may lead to economic opportunities like carbon credit for companies that invest in this method. So, where does it happen? OIF is tested in HNLC reagent. This means high nutrient low chlorophyll zone. This includes the Southern Ocean and North Pacific Ocean. One example is the KIFES project in the Southern Ocean. We study how iron help increase phytoplankton and carbon storage. So how does this help the climate? When phytoplankton absorb CO2 during photosynthesis, when they die, some sink of the ocean floor locking that carbon away, a process called carbon sequestration. The main goal of OIF is to enhance this process in order to reduce atmospheric CO2 and help mitigating climate change. The relationship between iron level and climate. When iron is high, phytoplankton grow more, absorb more CO2, and this can help cool the planet. When the iron is low, phytoplankton struggle less CO2 is absorbed, and warming can continue. So this tiny micronutrient or phytoplankton has a major effect on the carbon cycle and potential global climate. There are two types of OIF experiment: artificial and natural. Artificial when humans add iron, and natural when iron enters the ocean naturally. Experiments have been done in many places like the Equatorial Pacific, Southern Ocean, North Pacific, and North Atlantic. Most of these places are iron limited and good for testing phytoplankton response. For limitation affecting ocean iron fertilization, firstly, effusion light. Sometimes iron enriched water seems to deep beyond where light can reach, which stop phytoplankton from growing. Second, phytoplankton grazing. Phytoplankton feed on phytoplankton. Zooplankton feed on phytoplankton. If they eat them before they can sink, OIF won't work effectively. Third, nutrient limitation. It's not just about iron. Phytoplankton also need nutrients like silicate, zinc, and other to grow. Fourth, short residence time. Iron doesn't stay available for long. It can quickly sink or clump together, limiting its impact. Some experiments like ELFES were successful and showed the carbon sink into the deep water, but others like SOIREE and SEED1 didn't have long-term effect. The result really depends on the location, time, and environmental condition. Also, OIF can have unwanted effects like increasing N2O, a greenhouse gas, and causing harmful algal bloom. That's why more research is needed to improve the process. To improve OIF, scientists suggest doing larger and longer experiments for at least 1 year. Second, testing it in different locations like other parts of the Southern Ocean. Third, building strong monitoring system to track carbon and environmental effects, and using adaptive planning so the process can change based on the new information or challenges. To achieving goal in future OIF, the project must include firstly monitoring and verification system to track how much carbon is removed. Second, transparency, so the public and scientists can trust the result. Third, environmental impact studies to see how marine life is affected. And then lastly, adaptive management, so researchers can adjust the project if needed. That's all from me. Thank you.